Thank you very much. Okay, thank you for that kind introduction. Okay, it's been wonderful meeting the UX DX community over the last few days. It's clearly a very multidisciplinary community. So just so I know my audience, how many of you self-identify as designers? Okay, and how many of you self-identify as data scientists? Okay, good. Okay, how many of you are designers at a company that has a data scientist? Okay, good. And how many of you are companies that doesn't have a data scientist but you wish you did? Okay, so my goal is to make it easy for those of you who are at companies that have a data scientist to interact with them and to understand how they're trying to add value. And hopefully by the end of the talk, all of you will raise your hands that you wish you had a data scientist at your company. Okay, so as advertised, I'm Chris Wiggins, and I'm Chief Data Scientist at the New York Times. And I thought I'd tell you a little bit about that role and how it relates to the goals of UX DX. So part of the history of the New York Times is this kind of UX on the left, which is a dead tree that people interact with, and they spread out on their kitchen table, and they interact with it for a couple of hours. And when they have a particular job to be done, they get that job done by switching from section A to section C, or by flipping to a particular place where they know in terms of the layout of the information how that location relates to their user need. Could be crosswords, could be sports, could be, I don't know, what time the ships were showing up in New York City in 1851. And all that changed on January 22nd, 1996, when the New York Times introduced a website, which they reported on with the quaint title, "The New York Times Introduces a Website." And of course, all of us live in a digital world, so particularly those of you who are employed at any company with a website, you know that that means that you're getting abundant data about the way the users and customers feel about your product. So and right now, let's say up to 2022, the way that you interact with the New York Times is not probably in the form of a dead tree. Thank goodness some of you still actually subscribe to the New York Times in hard copy. It's wonderful. But you're probably experiencing it digitally. And that's the environment in which you may want to have a data scientist in your company to try to make sense of and also optimize the digital experience. You may be experiencing the core news product on a desktop experience, or you might be interacting with a wire cutter or other sort of non-newsy parts of the bundle, including cooking or games, and as of 2022, Wordle, and also audio content. So interacting with the New York Times now is a wide variety of user experiences, not just dead tree. Okay, so let me explain where you might put a data science team in that organization. And to explain that, I need to explain to you the org chart of the New York Times. Here's the org chart of the New York Times at its most coarse level, church and state. So the things I'm going to tell you about today are not going to be about the journalism parts. They're going to be a way that data scientists try to make numbers go up. So I'm going to tell you about a couple of problems in which the job of the data science team is to use those data in order to develop an optimized experience in order to drive some sort of enterprise KPIs. So we'll talk about that. And it's mostly going to be, therefore, about things that involve not generating individual stories, but rather not going out of business, like making the New York Times economically strong. So I'll divide that into a couple of stories. The data science team develops and deploys machine learning. So we'll be talking about machine learning today. How many people use machine learning in their day-to-day life? Okay, like 4. Great. Okay, so I'm going to tell you more about why you might want to partner with a data science team to use machine learning, why you might want to try to get your company to employ some people doing machine learning. And the stories I'll tell you today are about algorithmic targeting, which is in the lower right-hand side. And then I'll tell you 2 stories about algorithmic recommendations. And then I'll try to close with some lessons learned. So, as I said, algorithmic targeting is the first team. So algorithmic targeting is a team that we sort of christened in 2019 to try to think about, among other things, the paywall. And if you'd like to know more, there's a great blog post by Dr. Rohit Supakar, who wrote this blog post back in 2022 about the way we use machine learning as part of the paywall experience. So how many people have ever experienced a paywall? Good, I'm really just trying to get you to raise your hands there. Okay. Good. Okay, so the paywall's been around for a while. The paywall's been around since 2011. It was an experiment. There's a opinion guy on the right-hand side, so you can tell this is an old website. And people thought it was a stupid idea when the New York Times announced that they were going to have a website in 2011. Really smart people said things like, "It is destined for failure," Or here's 5 reasons, sort of we used to write listicles in journalism, 5 reasons why the New York Times paywall will fail and is why it's really dumb. And that was, written by somebody who knew what they're talking about. In fact, it was not doom. So things have worked out pretty well. Actually, by having a differentiated free pay experience, the New York Times has really defied this old adage that information wants to be free, if you know that old adage. Actually, if you read the original paragraph, it's a full paragraph that at the end says, also information wants to be expensive. All right, so the New York Times has had a pretty successful digital subscription project, and around 2013 is when I showed up. So New York Times profit is doing great, and it's good times, good times. Okay, so what is a paywall? So if you think about the paywall experience, one way to model it is as a funnel of people, broad in the sense that many people have heard of the New York Times. A few people show up and register, and that's one of the experiences that you might want a machine learning team to optimize, is when do you ask them to register? And then eventually they move to a higher level of commitment in their relationship with the New York Times, that is money. And that's the paywall, right? That's what the pay means in paywall. And so you might want to use a machine learning team to try to optimize that experience. And you need to think very carefully about what you're optimizing. As said in the introduction, you need to be really careful about what questions you're asking. Optimizing for the right thing is a good idea. Optimizing for the wrong thing is a bad idea. And that's another good reason why you want to have designers, UX researchers, and machine learning people all work together. We try to frame it to our friends in terms of thinking about the difference between prediction and prescription. Predictive machine learning has been in a lot of the papers. When you have an algorithm that can tell if a picture has a hot dog or not a hot dog in it, that is a prediction, right? You give it an image and it predicts what's in the image. When you have a chatbot that's effectively predicting the next word based on words it's been trained on, that is a prediction problem. But often when you hire a machine learning team, you don't actually want to know what's going to happen in the absence of treatment. You actually want to know what treatment is going to drive the particular outcome you want. So we try to help everybody understand that what we're trying to do as a machine learning team is prescription. So predictive ML is what will happen without some sort of intervention. Like I can look at people who use the website and predict who's going to cancel their subscription. And having done that back in 2013, the immediate response I got from my friends in product and marketing was, okay, that's great, but I don't really care who the at-risk individuals are. I want to know the risky behaviors, and more importantly, I want to know what are the things I can do to make those people not cancel. So we tend to think about this in terms of the modeling question, what is the best action in order to maximize some outcome? So we look at people's previous activity, which includes some intervention, some type of action. And then based on the action, then we try to predict the outcome. For example, whether the person subscribed in the case of the paywall. Good. So we typically don't know what would have happened to this person if we would have not given them a paywall, for example, or if we would have given them more access to the content. So I mentioned earlier that it's important to ask the right question. Actually, in the introduction, we talked about knowing the right question. So you also have to know, what do you want to maximize? You might want to get as many new subscribers as possible, in which case you should have a very hard paywall. Everybody should have to become a subscriber right now. However, then people don't experience the breadth and depth of the content. So you may lose out on the possibility of having more subscribers in the future. So how do we do this? Well, we do this leveraging A/B tests. You will experience A/B tests some point today as part of the content of this conference. We often refer to them as RCTs, which is sort of an older term, randomized control trials. Often we're not just doing 2 variants, we're doing lots of random things to random people in order to learn what works best. In the case of the paywall, it could be something like this. I'll describe it in the original language of the paywall. Instead of saying you get 10 articles a month and then you pay $10, imagine that you say to people, okay, you get 3 articles a month or 2 articles a month. And for those people, by doing it at random, you get an awesome gold data set for seeing what the trade-off is between getting as much engagement as possible and getting as many new starts as possible. So those are examples of 2 different business goals that you might have. One is a statement about how they use a product, and one is a statement that will make your chief financial officer happy. So how do we turn that into machine learning modeling? We do some randomized control trials. Some people get lots of paywalls, some people get less paywalls. We can trace out and learn from the data what the trade-off is between eating your cake and having it too, that is people exploring the breadth of content and people converting. And then we can show that if we have a targeted model, that means something that uses information about people in order to give different amount of friction or different amount of paywall to different people, we can sort of defy gravity and move off of that line. So this model is called Raptors, which is a real-time model. and it works. Okay, how many people here love math? Awesome. Okay, that's about 5 more hands than I expected. Okay, so how do we think about this? Well, one way to do it is to leverage 2 predictive models. One model that predicts how much engagement you're going to get as a function of things you were allowed to know before you decide how much paywalls you're going to give them, and the treatment. And then to balance between the two. And the useful utility of doing that once and then balancing it like a knob is that then your product friends can say, well, this month we really want more starts, or this month we really want more engagement. And you really can tune that knob between 2 different things you're trying to optimize at once. We actually used to have meetings called knob meetings where we would train that knob. Okay, so a lot of this is based on back testing. You do some random things to random people, and then you can learn what a new policy would do. And by do, I mean how it would lift KPIs or not. Even though 5 of you said math, you probably don't want to hear about Hayek estimation and self-normalized weighting. Just trust me, it works. And it works. It works in the sense that we can go optimize some balance between clicks and engagement. Sorry, between starts and engagement. Okay, so that's a story about algorithmic targeting, which is paywall specific. If your company doesn't have a paywall, you may not have exactly that problem, but you probably have content, and you might want to optimize which people see which content. So I'll tell you a little bit about the way we do algorithmic content recommendations. So content recommendations also has an old history at the New York Times. In 2011, the New York Times launched a recommended for you widget in the lower right-hand side and had a quaint little press release about it called the New York Times adds a recommendation feature. And so when it first appeared, it was a structureless feed in the lower right-hand side where you would see, like anything, like opinion content, hard news, recipes, all sort of in a structureless feed of stuff. These days, and by these days, this is a blog post from Dr. Anand Conan from 2019, we think about it as an optimization problem. That is, instead of thinking about, let's show people stuff, we think about what is the KPI we want to go up, like what is the number we want to drive, key performance indicator, and how do we design an algorithm that is an optimization algorithm in order to make that number go up. So that crucially involves experimenting. So I mentioned RCT, randomized controlled trial, for thinking about the paywall. Similarly here, you have to actually do something. This is a painful transition for a company. Often you want to hire a data scientist and you say to them, here's a bunch of data, make magic happen. It is very difficult to know what will happen if you have never done any intervention. And so, for the sake of your future data scientist friends, please consider at least doing an A/B test or doing some sort of experiment, because that is a gold data set for learning what is the optimal treatment to deliver. So as Dr. Conan writes in this blog post, we do this using a particular approach called contextual multi-arm bandits. Just so I know my audience, how many people have ever heard of bandits? 2, 4 people. Okay, good. Okay, so I'm going to tell you about bandits. All y'all are going to become bandit fans in the next 2 minutes. It's going to be great. So we do this using a technique which since 2007 or so has been called contextual multi-arm bandits. Bandits is actually a very old word. This is the first paper where anybody used the word. It's from 1955. They had this experiment with Harvard undergraduates where they made them press 2 buttons, and if they pressed the right button, it delivered a coin. But the thing is, most of the buttons were like a slot machine, and if you've ever been to a casino, slot machines are sometimes called one-arm bandits. So they call this a 2-arm bandit. And the tantalizing part of this old paper from 1955 is the little footnote that says, the optimum rule for playing the 2-arm bandit seems not to be known, which is true. There's like a whole field now of figuring out what is the right way to figure out in real time, should I show people the blue button or the black button? And the way you do that, of course, is you deliver both of them at random to random people. You have probably heard of A/B tests. How many people have heard of A/B tests? Okay, good. So A/B tests is something that, like, if you've ever been through a pandemic and you heard about people doing randomized, vaccines to random people, the reason you do that is so that you can learn from the data what the causal impact is of doing different things to different people. A/B testing is the term for this, although the idea in statistics goes back like 100 years. So what you're used to is, okay, I do random things to random people for 6 weeks. I show them A, B, and C. The idea of doing an adaptive A/B test is, as you learn from the data that option A seems to be better, rather than waiting until week 5 and sort of, throwing money out the door, gradually upweight the probability that you show people the thing that actually works. And this is from a very old blog post by my friend Matt Gershoff, illustrating it as a visual to try to compare and contrast A/B testing and bandit selections. But the other thing, this is like a mathematical observation. The other thing is you don't have to have a meeting. So when you have an A/B test, generally right around yonder, you have a meeting, and then one of the SVPs says, well, my KPI is really important. And then another SVP says, my KPI is really important. And then you have to duke it out, and the highest paid person opinions wins, which kind of makes everybody sad. So it's better if you just decide in advance, what number are we trying to make go up? And then you just let go and let math. And then a bandit will make that number go up, and everybody's happy. Okay, so we've been bringing sort of the gospel of bandits to a lot of different problems at the New York Times. For example, in this great blog post by Dr. Zhen Yang, where she writes about how we do algorithmic recommendations in a way that defends and advances news judgment. Right? Because one of the things about the New York Times, it is a brand conservative, publicly traded company from 1851. So it's not the kind of place where the editors are going to say, well, whatever, like optimize whatever. It's actually something where we worked very closely hand in glove with the editors to develop algorithms that are optimizing the right thing. And we worked with them quite a bit to think about what actually are we trying to optimize? What does success look like when we're recommending content to different people? So one of the things we did was we moved very much away from the idea of a little structureless feed in the lower right-hand side, which was the 2011 design. And instead, we started thinking about different jobs to be done and how there's really a different part of the homepage or the article site for all those different jobs to be done for the user. Does the user want to experience a set of opinion content or lifestyle content or Wirecutter content or maybe athletic content or dutiful news at the top? And all those different modules have separate algorithms optimizing different things. And we work with different editors who say, here's a set of articles that we think is the appropriate article to go into that particular widget. News, features, repromotions, and sub-brands. Sub-brands here meaning cooking, Wirecutter, athletic. The other step is to work closely with editors to say, okay, we can think about this in 3 steps, and the following is not like trade secrets. Almost every company that does recommendations will tell you that the process is thinking carefully about what is the action space, that's the technical term, it should be the list of articles that's going to go to a particular widget, then doing the algorithmic ranking, which means you've worked with editors to figure out what is the success score, like what is the number we're trying to make go up. And then applying any business rules. For example, they may not want 2 stories of the same ilk to appear by each other. Various finishing functions are applied. So now we have a process in our relationship with editors where we've made things very self-serve. I was talking on Monday about provocations, products, and platforms, and prototypes. And sort of once we had prototyped this a bit, then we got to the part where it was really a product. Like the data science team was building a product for editors, and the editors could do self-service. So self-service means that the editors can say, here's a couple of articles that we think are appropriate for this, and then the algorithm can optimize an agreed upon score, and then they don't even talk to the data scientist. So when there's breaking news, like, I don't know, the Queen dying was a big one for us, where when the Queen died, there was a lot of articles. And it was unclear, how should we go about promoting those all as the story developed. And that was an example where the editors had a self-service tool that we provided them, a product that we provided them to do that optimization without even talking to us. Okay, so that was a couple of stories, optimizing the paywall, optimizing content in a way that's in partnership with editors. Editors are not data scientists, so a lot of that involved finding common ground, finding common language, and iterating with them until we were literally looking at things, right? The thing could be a content or it could be a score. What are some of the lessons that we've learned in the data science team as an internal product team at the New York Times? One is this lesson that I really stole from Gartner. So Gartner had this blog post in 2012 or so about the difference between prediction, description, and prescription. So we try to emphasize to our friends that you can take a bunch of data where people do what they do and you don't intervene, and you can learn a model that says, for example, which users are going to cancel their subscription. But it's a bit like having a hospital that never gives anybody any medicine, and then you hire statisticians, and then you ask the statisticians to predict who's going to get better and who's going to get worse. That matters. We want people to get better. But if you're the doctor, you don't necessarily need somebody to predict what's going to happen in the absence of treatment. You really want the statistician to tell you what treatment is going to drive the outcome you want. So that requires you to get to a point where the editors, product people, or marketing people are willing to let the data scientists do some experimentation and possibly drive part of their process. So we've tried to emphasize the value of prescriptive analytics rather than predictive analytics. That is more difficult, right? You have to not only think about what are the signals that you think matters, but what is the number you're trying to make go up, and what are the levers you're willing to pull in order to make that number go up. If you're willing to think through all those three things, then you have the opportunity to turn the product experience into an optimized product experience. Another lesson learned, and this is from my friend Dr. Monica Rigatti, a blog post she wrote, I believe, in the summer 2019. She was working as a consultant, having already worked at LinkedIn and a bunch of other places, and she got tired of saying the same thing to people over and over again when they said, okay, we're just going to hire an AI person, and then sprinkle AI on the whole experience and get better. And she said, no, that you're doing it all wrong. That's not the way this works, and that's not the way any of this works. And in particular, you need to have a good data engineering team and have the tooling correct. And that's not the thing people usually blog about and get excited about, tooling. But the truth is, you're only doing a provocation if you just hire an AI person, but you're not actually building a prototype, let alone a product, let alone a platform you can stand on. You need first to make sure that you have really good data engineering. Then you can start thinking about making sure that your data pipelines are working. Then you can start making sure that the data don't have huge pathologies, the break in your mental model of how the data were created, how they actually were created. Then you can start thinking about what is. Then you can start thinking about what could be. A/B testing is the basics of doing some experimentation with the world and intervention with the world. Then you get to think about the fancy AI. So if you bring in somebody who's doing machine learning and you haven't really built out the data engineering function, they might be fun and they can do something provocative, but it's not really going to be the basis for the product unless you have the fundamentals correct. The other thing to learn, and this is another thing we were talking about on Monday, or maybe it was Tuesday this week, is the hype cycle. So the idea of the hype cycle, also stolen from Gartner from 2003, is that when a new innovation is introduced, there's a period when people are very excited about it. Often there's a good reason for them to be excited about it because the investors and the people who are selling the product are encouraging you that this thing is the best thing since sliced bread. And then when you start using the thing for a while, you may realize that it doesn't actually leap over buildings in a single bound, and et cetera, and then you experience the trough of disillusionment. There's tears. And if you drop it and never use it again, you will prevent yourself from getting to the efficient part of the hype cycle, which is the plateau of productivity. Or as I sometimes say, you move from irrational exuberance to rational exuberance. This is happening right now with AI, right? Like AI as a term has been around since 1955, but around November of 2022, a lot of people got very excited about AI. And that's great. For me as a machine learning person, I'm glad that people are excited about AI. And once I get them in with the gateway drug of whatever the latest AI is, I can tell them, how about statistics and predicting things? There's lots of things you can do with data. Let's do that stuff. So the inefficient thing for us all is that the technology is changing very quickly. If you put tens of billions of dollars of capital into a technology, it'll change real quick. The other inefficient thing for us is that everybody's like on a different point of this hype cycle at the same time. So it's a very difficult time to form alignment between different teams and different companies. Another lesson learned is varied voices. We try to hire people from a variety of fields. Neuroscience, computer science, mechie, biology, political science, chemical, physics, I'm just naming them off the top of my head here, applied math, cog-sci, geophysics. We try to hire people from a variety of fields. They really bring a variety of perspectives to this. Those are some of the lessons learned. If you'd like to know more of the lessons learned, there were 2 books that I wrote about data during the plague. The one on the left is with a history professor, so it's more of a book for normal people. And the one on the right is with some very august and accomplished computer scientists. It's a little bit more technical. Both of them, I think, will give you a useful view on data and how to put data to work, including the history and ethics of data is a real focus on the book on the left, and how to think about putting data to work in a product is really the focus on the right. And with that, I think we've got a little bit of time for questions. Thank you very much, and I look forward to your questions.
Thank you, Chris. Wonderful. I'm forever now going to think about physical newspapers as dead trees on kitchen tables. Thank you for that phrase. Sure. Wonderful. All right, so as we get some questions in from all of you, as those start to come in, I'm curious, Chris, in the beginning of your talk, you mentioned you want to optimize for the right things. Right. And you spoke about jobs to be done and kind of understanding where people are in that that peak. Tell us a little bit more about how those conversations work in the room when you're talking with cross-functional partners or even with your team from all over. How are you trying to optimize?
Right. So those conversations can be very nuanced for different parts of the org chart. With our friends in business, particularly with a subscription product, as opposed to maybe an advertising product where the revenue is aligned with something that happens in a few milliseconds, it can be hard to think through what really are we trying to get people to experience with our product, because the thing you want to optimize for is like a long-term relationship with the subscriber, and that's slow. You have to wait 6 months to figure out if somebody's going to stay a subscriber for 6 months. So that's one of the reasons why we think about how we want to eat our cake and have it too. The other thing about waiting 6 months is effectively the laws of physics change, right? So here it's not the laws of physics, it's the way users behave, it's the state of the digital product. Who knows, we might acquire Wordle or something, and so the way people interact with the product totally changes. So the model that you build predicting what's going to happen in 6 or 12 months is immaterial because effectively all the laws have changed. So that's another reason why when working with business partners, you really need to think about what are you trying to optimize, particularly for a subscription product where there's sort of slow metrics. For the editors, we worked really hard to think about, clicks, have a variety of signals, right, that you get. If somebody clicks, it could mean that they read it and then they realized it wasn't for them. So you might want to think about clicks and actually engaging with the content. Of course, there's an infinite number of ways to measure engagement, and not everything that can be counted counts, and not everything that counts can be counted. So we worked hard with them to think about not only digital engagement, but also editorial importance. So one of the things that's described in that blog post about working with the editors is how would we put a score on editorial importance? And for that, the behavior that we tracked was not the behavior of our users, it was our editors. So we looked at the way editors promoted different content and learned from the data, okay, based on what this digital asset is, here's how we think an editor is going to promote this piece of content. That was just the beginning, of course. We had to work with editors to actually look at the ranking and see if editors liked it. And that is, not easy to quantify, right? As you know from doing UX research, a lot of times it's really like sitting with editors, asking them how they feel about things, and then trying to think. The hard work for a machine learner is how are you going to take somebody's qualitative feedback and implement it as a change in the model, right? And that's not easy. That's why we hire people who I think are good communicators, not just good at the boop, 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 computers.
Yeah, that communication is essential as well. Thank you. We've got some great questions. What's your perspective on ethics? And I know this is part of your specialty. So there's a question here on ethics of using algorithms and changing how people read news for KPIs.
Yeah, that's a real tough question, and in a way I sort of threw a grenade at my own foot by mentioning the fact that the left book on the left is about the history and ethics of data. So my other hat, which I didn't talk about today, is from the academy, from being a professor. And the way that people think about ethics in the academy has been really stress tested for about 50 years under a particular framework around principles. So operationalizing ethics in academic research is often framed in terms of a set of principles, which I like to cartoon as rights, harms, and justice. Those three principles give people a shared vocabulary for having at least difficult conversations about those trade-offs. For example, you might develop a product that's so good that you just want to roll it out for everybody and not tell them. So that's an example of leaning into harms, but not leaning into rights. You're leaning into what do you do that's a benefit for people, but you're not leaning into giving people informed consent. So for journalism, there already is a very long conception of journalistic ethics that has been hammered out by centuries of journalism. So one of the things we've been doing is working with the newsroom to think about how do we reconcile ethics in the form of a long checklist, ethics in the form of a small set of journalistic principles like trust and transparency, and reconcile them with the way that data scientists and academics have thought about ethics in terms of giving people informed consent and also monitoring things so you actually know long-term what is the impact of algorithms that you roll out.
Thank you. All right, there's a question from Kate about data visualizations in the New York Times. They're phenomenal. I completely agree. How do journalists work with data scientists to create these visualizations and determine what to prioritize?
So that is a great team, and I want to not cause any confusion with people at the New York Times. That in terms of church state, like there's a great team on the church side that does data journalism, and another team that does great data visualization, another team that's data graphicists. We talk regularly, but in many ways, the skills that my team has focused on are not the skills that they need. For example, part of working in data journalism is making visualizations and explanations that are clear and easy to understand, that you don't need to unpack and say, what's the machine learning algorithm behind it. There's a couple of rare exceptions, like years ago, ProPublica had this great story where they reversed engineered a decision tree for Obama fundraising emails. That's when you have to like explain as part of the story how a decision tree works in addition to how it works, what it means in terms of politics. So generally, we try to focus on things where we're optimizing a KPI and we're developing something that's in production, like it's actually rolling out in prod and is a reliable piece of infrastructure. So we tend to work on different stuff, although we talk regularly. I've definitely benefited from them thinking about how to visualize stuff in a way that's interpretable. Occasionally, I hope they've benefited from talking to me about modeling things, but I have to say they're very good at their job. So the job that they're doing is sufficiently different that I would say we're really solving different problems, and they're quite good at the problem they solve.
Absolutely. And speaking of people solving different problems, there's a question about UX researchers and data scientists working together. Reminds me of the fabulous conversation we heard yesterday about the peanut butter and chocolate, for those that were there, the analytics and UX research, but I'm curious at the times how that transpires.
So that is one of the reasons I was so excited to accept the invitation to come here. Is I feel like I, as a data science lead, have not done enough to talk to designers. I do occasionally, like when we're trying to brainstorm on a new product, we're always interested in, for example, what UXR has been done. You know, when we're a recent one, a data scientist working for me was thinking about, you know, maybe people have the following behavior and we could model that. And I said, that's great. Before we start writing code or looking at data, we should talk to the UX research team and see if they've already done research on that. So I definitely try to work with them. The other sort of different way that the field of, but not the group of UXR impacts us is if we're building internal products, we actually know our internal market. So when we build out editor-facing tooling, which I didn't talk about today, I can remember in 2015 saying to one of the machine learning engineers, you are now the ambassador for machine learning to the newsroom. Go shadow them, go read this book on analytics for success and how to think about using analytics to drive products. Go like understand their pain and like empathize with them, and which was not like a natural place for that particular software engineer, but he did a bang-up job. So we definitely use those principles and really think about when we're developing internal product, how do we go and meet the people who are allegedly going to use it? How do we make sure that we're doing iterative and incremental product development so that we meet with them regularly? We ask them, do we have your permission to continue? We try to, you know, build our features in slices rather than layers and like build out one little MVP solution and try to get the reaction. And that's the building in slices rather than layers is really important because we often will build a very simple data science solution and then do the organizational integration, meaning have we built something that people can actually integrate into their process or not? Once or twice in early days, we'd build out something really complicated, and then we showed it to the user, here meaning editor, and they were like, well, that's interesting, which is really sad when a technologist spends like 6 months building a thing, and then the user is like, it's interesting, but I can't really integrate it into my life. So that sort of organizational integration is definitely something we focus on in data science for building internal products that win.
Amazing to hear. Yeah, you definitely want to have those learnings sooner.
Yes.
In the funnel than after you've spent all of that time.
It's very sad
developing.
for the technologists if they build something that people don't want.
Yes. Okay, well, that's all our time for questions. Thank you all for your fabulous questions. And thank you, Chris.
Thank you.